Good morning, everybody. I'm really pleased to be there. And the first thing first, and I'm Italian. This is the second talk I give in English, so be patient with me. I'm pretty used to speaking Italian, but this is the second time in front of an English audience. And so the main thing is that if you can delay questions to the end of the session, it would be much better for everyone, especially for me. So who am I? My name is Mauro Servienti. Mauro, that is the easiest part. So I'm the CTO of a company in Italy called Managed Designs. Here is a bunch of contacts, so the email, the Twitter account, the English blog. I'm also a partner of the company, and the company I own is the RavenDB partner with Hyper-Rated Rhinos for Europe. I'm also an service bus trainer and support engineer. And it happens to be also a Microsoft MVP for Visual C#. My background is, despite the title, the CTO title, I'm basically a developer. I've been a developer for the last 15 years. And I started with HTML and a lot of imagination, where the only thing you have is what, Notepad. Then I moved to server-side development, and I ended up with the WPF. That is my beloved WPF. And 2 years ago, because of a project, with a customer, I get back to the HTML development using AngularJS. And the demo will show you in the next session will be based on AngularJS, but that's just detail. And I have to say that I really love and hate JavaScript. And Judah can understand me very well, I think. So let's try to reverse things and start with the demo and then take a look at some slides. And one thing that I really love of RavenDB is the "it just works" sentence. It's everywhere. It's the first thing you see when you arrive to the website. And what I want to try to show you today is that, well, just a bit of background more. This is an introductory session about document database modeling and document database in general. And what I want to show you is how easy it is to start up and get running with RavenDB in seconds without even thinking that there is a database behind you supporting you at the moment. So I have set up a console application. Can you see? Yes, it's working. I have set up a console application. There's a server running behind the scene. I've just downloaded and double-clicked on the, well, that's not really true, but we'll see in a minute. I've just downloaded it and double-clicked on the startup.bat command. And I've started writing a bunch of code and nothing else. There is no mappings. There is no impedance mismatch. There is nothing. It just works, basically. So let's leave aside for a moment the create document store. Let's say that we have something that set up the connection to the database. And what we want to do is see how it works. So we fire up the debugger. And if we step, it works. Let's connect. Let's do it. It's doing a lot of things. And then the first thing we try to do is to connect to the DB. If you are used to a SQL connection, that's what we get back right now. So we can safely compare in our mind the open session command to let's create a new SQL connection to the database. It's not under the hood. It's totally different thing. But from the application point of view, it can be seen something really similar to that. Or if you are used to an Hibernate, that is exactly the same thing as doing session factory.open session. And if you think about it, it's pretty easy to think that the the guy that participated in the Hibernate code base does a really similar thing because it's pretty easy to use. And what we do is just open a session, create a new instance of a class, and it's just a person. It's just a plain old CLR object, and we'll get to it in a minute. And we are assigning a couple of properties, and we are asking the session to store it. What happens behind the scene is that nothing happens at the moment of store with database. Well, it's not really true, even in this case, because there's the assignment of the primary key. But the fact that we are telling to the session, OK, when the transaction will be committed, I want you to store this object into the database. Okay? And then we move on. We set up another class. We assign a property that in this case is what we can call a denormalized reference. We'll get to it in a minute. We want to store even that too, and then we call save changes. At this point, what happens is that the transaction is committed to the database, and data is written to the database for us by RavenDB, and that's it. Let's have a look at, before moving on, at the classes over there. The person class is nothing. Let me zoom a bit. The person's class has nothing special, no mapping attributes, no, I do not need to inherit from anything. It's just a class. It has a interesting, from my point of view, semantic characteristics. That is the ID property that I have not assigned in any way is a private property, and it represents, by the convention, the primary key of the class itself, of the document itself in the database. And the really interesting thing is that the RavenDB can assign it for me, in this case because it's linked to a convention. It's a string property called ID, and since it's null, when the instance arrives to the database, it will be automatically assigned and generated by the database. But from the code point of view, what I really like is that it's a private property. So from the meaning of the property is that it's immutable. It cannot be changed by the user using the property, the class. Then we have this implicit operator that I use to create the normalized reference in order to assign references from a document to another one, because in the RavenDB we do not have relations. But we'll arrive to in a second, and let's get back to the original code. One other thing that I used to show to customers, the first time I showed them the RavenDB, forgive me about the fact that regions are still in Italian. I'll promise you that as soon as I give you the demos, they will be translated in English. And this is link person search, the translation. So the other thing we can do is that it's so easy to search for things in RavenDB because we just open another session. We issue a query using link. The language I suppose everyone is used in the end. And we just not need to think about anything. Maybe you have already been told that the only way to search in a document database as RavenDB is to define an index, because there is no way to look for documents without an index. But the API is doing that for us. So we don't need to think about anything. It just works. Okay? Maybe this is not the best approach for a production database, but to start up things and to allow a really easy development approach, this is a really good approach, because we can be up and running in seconds without even thinking at what's going on. And we issue a pretty standard query, and we get back the 10 documents. There were much more than 10 persons in the database, because this is the demo I used in Italy quite every time. And so what we can see here that we can use the take operator to do a paged query. And so we have basically all the features we are used with the ORMs. We can have it also in RavenDB, except basically for all those features that are prettily tied to a relational databases, such joins, for example, that does not exist in a document database. And then we can move on. And there's another query that is basically a much more RavenDB-like query. It's a full text search query done using a Lucene syntax. And it issues the worst Lucene query ever you can do, because it's a contains query. So it's a star S star. And it's something that should never be done, really, with the Lucene, because it's the worst thing that Lucene can handle. But we are still using the link API, using a couple of more operators, that is basically the search operators, that is a RavenDB operators, and the as projection operator that is required to extract a specific projection from the database. We'll see the usage of as projection better in the next session about CQRS and event sourcing. But what I want to underline once more is that it's so easy to have things up and running, and we'll be in a second to how the indexing stuff work. And the last one is it's a much more complex query. That is something really hard to achieve with SQL databases, with the relational databases. In the last couple of years, I've worked with a customer that works in the fashion fields, and their concept of products is pretty strange because they have just a description and then a list of attributes. There is no definition of products. It's really hard to define a product for them, because a T-shirt is a product, such as a belt is a product, but they are defined in the database in a completely different way. And expressing that in a relational manner, it's pretty hard, because the only thing you can do is a one-to-many relation with a vertical table, basically, where we have 3 columns, the attribute name, the attribute type, and the value. But that means that all the values are flattened basically to a string, and then you have to convert it back in your application when they get back. And express a query such as, give me all the T-shirt, where these attributes follows in these ranges. It's a really complex query for the relational database. There's the CTE syntax in SQL Server to achieve that. But if you are used to have an ORM on the other side, it's pretty complex to map that to the ORM usage. And that's why developers tend to use the ORM instead of the power of the database underneath. And using RavenDB, and in this case, the Lucene power, it's so easy to express a query when we say, OK, I'm looking for all the products where the attribute called taglia, in this case is size, okay, is in this range. And I want them sorted by range that is a specific Lucene syntax, saying that the value of the attribute is an integer. So for everything for Lucene is a string. So we are telling Lucene, OK, when you order them, when you sort them, think about it as an integer. Okay? And if we take a look at the, oops, where's the stop? The products class, it's just what we want to express. We have the same ID that is private, the name of the product, and then a list of attributes. And the document is stored as is in the database, and it just works. But the most amazing thing from my point of view is that all we have done, this is the old and legacy Silverlight Studio, connected to the database. We have just finished writing things, and we have orders, people, and products, and stuff like that. And maybe some of you will notice that we have strange key names, because if you are used to RavenDB, usually you don't see this portion of the key. So you're used to store an order, and you have orders / a number, a progressive number. But in this case, what was really easy was the fact that we are running against a sharded database made of 3 different databases. And the 4.1 was a slave replica of all the 3 shards. So the API made it completely transparent to the user that we are saving documents on different databases, and we are querying documents from different databases, aggregating them when they will get back to the client. And that's amazing, okay? Because we'll see that the sharding is hard, because you have to carefully think about how to share the data. But once you have decided how to shard them, the API is so easy to be used, and everything just works. Okay? How can you set up all this? If you take a look at the create document store, all the magic is there. We are setting up 3 different document store, where the document store is the singleton object that represents one server. And there should be, well, it really depends on the use case. In one application I'm working on, I have several document stores, because it's a multi-tenant application, and you have to decide which database is on which server, and it's pretty complex stuff, but we don't care. As a general approach, there should be 1 document store per server, and because you can define a default database for that document store, and if you want to connect to a different database on the same server, the open session method has an overload that lets you express the name of the database you want to connect to. And what we are setting up is that we are setting up a dictionary where the key of the dictionary is the name of the shard. It's just something that we decide up front. There's nothing to do with the sharding topology. We can call it Mickey Mouse, Daffy Duck, and stuff like that. It's not important. And we set up a document store for each shard, expressing the URL, and in this case, the default database. And then we define the shard strategy. What a shard strategy is? A shard strategy is what explains to the RavenDB client driver where to store data and where to read data from, given a query or given a store request. So we are basically saying, OK, for each company and for each person, do a blind, what is called a blind shard. So it's basically distribute data across servers, trying to balance them across the 3 servers. For the product, we are saying, OK, shard based on the product ID and put them every single product on the S03 server. And for the order, we are doing a pretty stupid thing in this case, but we are saying, OK, if the customer type is people, put it on that server. If the customer type is company, put it on the other server. Okay? We can, generally in production, what we can use is to shard the data based on the geographic distribution of servers, and we want to try to put documents as near as we can to the user. So if we have, as Oren said, if we have a headquarter in Europe and that headquarter in the US, we try to put all the US orders in the US, and we'll try to put all the Europe orders in Europe. And we express the shard key in all the queries, saying, OK, I want to query this order given these criteria, where the location is Europe. Okay? So that the query is resolved on the nearest server. And we know that if a user in Europe tries to access data from the US servers, the client API just will give the data to the user, and it will be slower, nothing else, because these servers are on the other side of the world. And that's it. But from the client perspective, it just works. What is really, and then in the end, we set up a sharded document store passing in the strategy. The sharded document store is basically an I document store as everything else. So it just works. I was trying to say something that I rapidly forgot. So the last thing we do is issue a call to index creation, create indexing. And what this does is to create all the indexes we need on every single database. So it just do everything for us. And we can change, in this case, the shard strategy, and all the indexes will be created in the right place for us. The last thing we set up is the replication definition. What we did is just to install the replication bundle on each of the shard server, and then we set up the replication on the shard, telling, OK, replicate data on the slave server, and nothing else. On the slave server, all what you have to do is to set up the replication bundle, nothing else. There is no configuration at all. And basically saying, OK, here is in place the replication bundle means that you are a slave. And if anyone tries to connect to you, trying to replicate data to you, just accept it. So what we are looking is the replication server. What I really like is that the shard API is partially exposed to the user. So what we can do is, when you shard data, there is an interesting issue. What happens if the query tries to read data from a server that doesn't answer? So you have 3 servers, you try to issue a query, and one server didn't answer anything. You cannot connect to that server. It really depends on the use case, because there may be use cases where you just don't care. Okay, I have enough data to move on. Maybe Amazon behave like that. I want to show you the best that I can do without saying, OK, there's an error because I want to try to sell you something. There are cases when it's really important to advise the user that something has gone wrong and maybe fail. Gracefully fail, but fail. And the API allows you to decide per query what the behavior will be. There's basically a callback that we can attach to, saying, OK, there's a server that didn't answer to the query. What do you want to do? Well, you want to fail, you want to, and stuff like that. And from the replication point of view, what I really love is that the replication is not there only to achieve distribution of data and replica of data, but also to being really affordable. I don't know how to say it in English. In Italian, there's a high availability, that is, servers are available, but there is nothing that prevents you to write to one server, that server fails, and you have lost data. And then there's the other term that I do not know how to say in English. That means that I want to write to that server, and I want that server tells me that the write is committed only if it has been able to replicate to at least, say, two more servers. so that the client is sure that the data is stored and will be available even if the server will fail right after the write operation. And that can be expressed per query in the configuration of the document store while it's set up. And where are we? This one. So what we have seen is that you download it and run in seconds. Well, that's not really true for the demo we have done because they're the shard setup and replica setup. But without setting up shards and the replica, it's really seconds. We use plain old CRR object. There is no configuration of objects. There is no mapping. There is no impedance mismatch at all. There's nothing. Just object in memory that will be stored and loaded from the database. We have link queries. That is for the, I'm currently working with a huge team of people at the customer coming from the entity framework experience. And they are not, we can say that they are junior developers. They are used to graphic designers. They are used to Microsoft T style things where everything can be drag and drop and it just works. And they are finding it really easy to move from the object context style thing to the session style thing because it's basically the same. And the link, in this case, link you, I don't know how to say it, how to pronounce it in English, link, does it work? Okay. Link is the biggest gift you have done to them. Because it's, let's compare it for a second with the MongoDB C# provider. It's just amazing how link works for the end user because it just expresses queries. The only thing the end user should not do is to try to do a group by in a query or to do a join in a query because it has no meaning from the document database point of view. But it's the tool that has no meaning in this case. It has a really powerful approach to things that are commonly hard with a relational database. And first thing that comes to my mind are the full text search stuff, or all the stuff powered by Lucene in this case, and the small sample we have seen speaking about attributes. So when we have the shape of the document that is changing, we cannot express it like rows and columns, but we have to make it vertical, and it's really hard with the relational database to achieve that. And setting up shard and replica is really, really, really easy. Well, shard in production is not so easy. You have to carefully think about it, but replica is, that's it. It's really, really, really easy. The topology of the demo we have seen is this one, and it's pretty easy. There's nothing too special to say about it. And is it really so easy to use it? I think that the only answer is yes. And what we need to do is just a matter of a mental switch, trying to move away from the model we have been forced in the last 20 years. I think that everyone, like me, tends to think in terms of rows and columns. Okay? You hear someone speaking about a problem about something to be solved, so a functional requirement, and you start thinking in terms of rows and columns. And that's the biggest mental switch that must be done by the developer approaching, in general, a document database and RavenDB also. So let's start from the beginning now. What is in the end a document database? It's a document-centric stuff. So we must stop thinking in terms of tables and rows and columns, and we need to start thinking in terms of documents. And if someone among you is starting to think in terms of aggregates, from domain-driven design aggregates concept, that's the biggest deal. Because if you start thinking in terms of aggregates, your life will be much, much, much easier with RavenDB. Because you forget about the fact that there is no joins. And you don't need joins in the end. Because in our life, joins doesn't exist. We tend to denormalize everything and get back to the origin of something to have an update about that something, and then denormalize it again. So the document databases abandon the relational concepts. They are usually schemaless, and the fact that are schemaless is both an advantage and not such a great advantage, especially with junior teams. That tends to mess up things, mess around stuff really easy. But given the fact that even at the Showmaker shop, there are a really huge amount of data in these days. It's really, and the amount of data is continuously growing. It's really a good thing to have a schemaless database, because if you think about an alter table statement with tons of indexes of that table running on a table with millions of documents, it means that that table will be unavailable for a lot of time. And the ability to evolve the schema without changing previous document schema is pretty cool, because you don't have to think about what's the meaning of this column that last month didn't exist. And you are in a situation where you say, OK, I have added the birth date column. It's a required property, but I cannot mark it as required on the DB, because all the data do not have a birth date. And I don't want to update everything, because a month ago, the birth date has no meaning from that point of view. So you end up saying in the DB, OK, that's nullable. And you start changing your code to couple with the fact that the nullable property, if it's null, has a meaning, but how to express the fact that has not been set. And you start dealing with date, time, mean, value. And you say, OK, if it's null, means that is a data coming from a month ago. If it's date, time, mean, value, it means that has not been set, so I have to enforce the user to set it. And it's crap. So you are dealing with something that is not what you are trying to model. And being schemaless means that you can deal with it without any issue, because you have documents with a date property, a birth date property, and document without. And that's it. And the other interesting thing is that document databases are taught with scaling in mind. Basically, the issue is that, well, I think that we already know why we have relational databases that won the battle 30 years ago. And now, relational databases was not taught with scaling in mind. And the really only option with the relational databases is vertical scaling, so add power to the machine. But vertical scaling always have a limit. There is no way to, well, maybe there is a way to grow, but it's a matter of how much does it cost. Since we are not the NSA, and the only thing we can do is to split servers. And currently, the option we have with the relational databases, for example, is the SQL 2012 always-on feature. But the interesting thing is that you are going to lose the DTC. Microsoft said, OK, if you want to have the SQL always on, forget about the DTC. So they are starting to realize that if you want to scale, you need to forget about consistency. And this is the only option. It's basically a compromise. So we are having something back, leaving something behind. And consistency is something that we do not really need. And if someone of you has thought about bounded context from the domain-driven design point of view, that's what consistency is about. What we really need is just to be consistent, or try to be consistent, within our small garden, I would say in Italian, within our context. We don't really care if the Orent context is out of sync, because it's someone we can go to Orent and ask for fresh data, and then they normalize that back to us, and it's not really an issue at all. So we have said that document database is about documents. So that's what we have in the database. It's a JSON serialization of a class. In this case, we have some interesting things because we are expressing relations, if you think about it, that in a relational databases must be expressed using different tables and must be resolved using joins. But in this case, we don't really need anything like that. Because if we have a list of blogs, in this case, a blog has no meaning without the blogger. And so why do we need to have a different document to express a blog? We just embed the blog document within the blogger one. And we do not need to do a join to retrieve data. On the other side, a relational database forces us to have a join to retrieve data because of the schema that distributes data. In the end, why do we really need a document database? Well, we have already said all of this stuff, so let's get to the hard part. What is really hard when switching from a relational model to a document-based model? And I have to say that the first thing is that shard is hard. There is an interesting discussion going on with a guy called Chris in the mailing list that is about how shard works and the fact that I expressed my disappointment, maybe it's too strong disappointment, to the fact that the shard key is in the document key, but in the end you must live with that. You have to, the sample I did is wrong from a center point of view because in the shard key there was S01, that is basically the name of the server. Okay? And now imagine that you want to change the shard topology. You need to update keys because the shard key changed the meaning of the document. And we all know that updating an identifier maybe is not conceptually the best thing to do. It really depends on the use case. So we cannot say up front that sharding is hard or how to manage shard strategy changes. We only need to realize that changing shard in production is one of the hardest things ever. And in the mailing list, I used to give an example of what happens in Italy with mobile phone numbers. And we have the number prefix and then the number. And the number prefix is linked to the operator, to the mobile carrier, sorry. But then the law allows you to change the carrier without changing the number. And that's a big deal because the prefix basically is the shard key. The prefix tells to the way you are calling, okay, go to that operator. But when you change the operator, your shard key changed the meaning because it's not pointing to the operator, to the old operator, but it's pointing to the new one. So basically, I suppose that there's a sort of a enormous central database that does the mapping for you. You arrive with a number, and the database tells to the carrier where to send the call to. And in that case, the shard key cannot be changed, because changing the shard key will change my mobile phone number. So we have to couple with that and move on, living with that problem. And that's only to say that you have to carefully think about how you want to shard your data before going to production. And something really important is that I deeply think that it's impossible to set up shard after you have gone to production. You have to carefully think about it and upfront. The main issues that people coming from relational databases faces when arrives to a document DB are the missing relations. Basically, they miss the class diagram. The fact that they can set up on an enormous monitor the biggest class diagram ever, saying that, oh, wow, I can do order.items, square bracket, 12.customer.addresses, ... And that will be expressed with the worst join ever. But they are pretty happy with that, because on their machine everything works. Then in production everything fails. But that's so the first thing I try to tell to customer is that there are no foreign keys. Wow, I love it. There has been a standing ovation over there. And this is the first thing that customers say, what? I cannot do a join? No, you can't. If you think about it, you do not need to express join across documents. Because if you think of documents in terms of aggregates, you never need to express joins across aggregates. Aggregates are the isolation level of your data, and they must all be in the same document. If you try to save an aggregate to a relational database, then you need joins. But that's just a technical problem, because if you have an order and order rows in a relational database that must be stored in 2 different tables, and in order to retrieve them, you have to set up a join. But the aggregate itself is just a single document. And the fact that there is no way, well, there is a way to express joins in RavenDB, and this load document. I've asked Oren to strip it out. Because I have a customer that comes back to me saying, OK, it is really slow. We are having pains in production that I went to them, and I saw a couple of indexes with 19 load documents in the index, because they are basically using a relational model on top of a document database, and it cannot work. It was a pain. I said, oh my God, what are you doing, guys? And we redesigned everything using the normalization and stuff like that. And the fact that we don't have, in my experience, this is the biggest issue with customers. And in the next session, we'll see how embracing CQRS and event sourcing in order to get back the most benefit from a document database. And as we already said, if we start thinking in terms of aggregates, that's pretty easy. We have a one-to many relation expressed in the same document, because it's a blogs, and they are a single document. And if we want to model a sort of a foreign key relation, what we can achieve is this type of documents using the normalization. Basically, what we want to say is that why the hell do I need to do a join or more than one query to get back the data that I really need? So I want to display an order to the customer. Do I need to really load the product? No. I just need a description of the product and maybe the unit price I sold the product in that specific order. So if we think about it, denormalization is what we live with every single day. Invoices are the primordial form of denormalization. No one had ever thought, well, I've seen it, I have to admit it, that products in an invoice row are just a foreign key, because as soon as you update the product, the total invoice price will change, and that's impossible, right? So if we want to live with the normalized document, what we can do is just this. Just denormalize the stuff we need in the shape we need in the main aggregate. And in this case, the order aggregate is the owner of the order concepts and is just holding a read-only form of the customer data that it needs. It's obvious that the customer document maybe does not have a full name property at all. Maybe it has a company name, a VAT-in, and stuff like that. Right? But do we really need on the order to have all this data? No. We just need in this case, in this pretty simple case, a full name, and we bring with that the customer ID in order to be able to update the normalized version if we need it, in order to understand from the customer point of view if there are customers used in some orders, and in order to have from the application point of view the concept of foreign key. But from the database point of view, there is no enforcement at all on this one. There is no one telling us in the database engines, unless we write a trigger for that, that you are trying to delete a customer that has been used in order 1, 2, 3. Okay. So what we need to really start to live with is denormalization. Denormalize all what you need to denormalize. In this case, it's not Greece is the word, but it's really hard to, I'm used to use a lot of idiomatic forms when I speak in Italian, and in English it's too complex. So start to thinking about in terms of aggregates and not in terms of the model you want to save, but try to model the world you want to work on. And then since everything just works with RavenDB and you can store a bunch of data in the shape you have modeled in memory, it's so easy, start to think about the shape of the data in the DB only when you have maybe performance problems or concurrency problems. If you have really huge documents, maybe it's not the best way to deal with every time with huge documents, and maybe it's much better to split them into the database, but do not do it up front. Just do it when it comes to the problem. Or if you have, Oren used to have a sample speaking about blog comments, you basically can say, okay, a blog post is a document, and comments is an embedded collection. Now you have to deal with concurrency, because we are going to append blog and comments to that main document. If me and Judah go to the same blog post and say, okay, add a comment, in this case, since that we suppose that there will not be thousands of persons doing the same things all together on the same blog post, we can say, okay, my update request will fail with a concurrency exception, and I simply retry. So the second time I load the document, I get back the blog post document with comments and with the Judah comments too, and then I'll add mine and set it and save it. But if you have a high concurrent situation where you have lots of writes to the same document because the blog post is the same document, maybe it's much better to split it and add documents to the database. It's in a sort of a insert-only manner, and then use indexes to rebuild the original document, the shape of the document you wanted. But what do we really, given the fact that we live in a denormalized world, what should we really take care of? Most of the time, if we want to set up a word, a real word using foreign keys, we have problems. So we denormalize everything. So we don't have to bother anything about foreign keys. We just need to update the denormalized version of the data when we really need it. Is it really an issue in the order sample before that we have denormalized the company name? Do company names change so often? I don't think so. Maybe if the company name changes, it means that it is a new company, and old orders should be attached to the old company name, because at the time of the order, the company name was Managed Designs and not Hibernating Rhinos, supposing that Managed Designs changes his name into Hibernating Rhinos. So if we carefully think about the data we are managing, we don't really need to update the normalized data so often. So we just need to deal with update the data we really need. And we can do that in a really lot of different fashions, such as from batch jobs to indexes. There's a lot of stuff that helps us to do that in. Do we really need to take care of deletes? I think that Oren really loves deletes. Every single blog post of Oren about replication deals with the awfulness of deletes. If we denormalize everything, we do not really care about deletes. Because if we delete a customer that is used by an order, within an order, the order itself is in a different bounded context, and the order itself still lives without the original customer, because it has all the data required for that order to go on living. That order issued 3 months ago must be immutable. So we can safely delete the original customer, and we can safely ignore the fact that the order has a reference to the customer. Maybe from a business point of view, we do not want to allow the application to delete customers that have been issued order to. But that's a business problem. So what we want to do is to switch and stop thinking from the point of view of the order and start watching from the point of view of the customer and say, can this customer be deleted? Not really, because it's used in those orders, but it's not a technical problem, it's a business problem. And that's why we generally use soft deletes. So we have an isDeleted property, or in RavenDB, maybe it is much better to have an isDeleted metadata. So we do not introduce technical properties into business documents, and you use the metadata of the document to express the status of the document that is not related to the business at all. The other biggest deal is Acidbase. I also had an image of Arnold telling to Will what you're talking about. But Acidbase, the first time I used to say to customer, okay, let's imagine like this. You write data, you query for your data, and your data is not there. And all the customers say, what? Are you really joking with me? No. It basically says that we have to start to deal with eventual consistency. That's it. It's pretty easy. We live in an eventual consistent world. We do not try to use transactions when dealing with the kitchen. OK, let's try to do some pasta. If it fails, roll back. No, it doesn't work. If it fails, there's boiled water everywhere, maybe. So what RavenDB brings to us is a really interesting approach from my point of view compared to others. I used to work with MongoDB in the last 3 years at the customer. And compared to others, I really love the fact that store and loads are ACID operations. So if you store a document, it's a transactional operation. So if you, in the same business transaction, if you store a set of documents, they will go all together to the database, or nothing will go to the database. And you have a rollback of all the requests. And once you have keys of documents, a load operation is always ACID. So if you have just stored that document and you try to load that document by key, the document is there. There is no way you don't have your document back unless you haven't put the document into the database. The only thing that is base are queries. So what can happen, and I used to try to explain to customer that it's a matter of milliseconds, so it's a problem of computer time point of view, not human time point of view, is that you store a bunch of documents, you try to query for that documents, and not all the documents are returned by the query. Not all the documents you expect are returned by the query. It's just a matter of dealing with the indexing engine that is working to index all your documents and get them ready for you to be queried. There's an API to deal with that. So what you can do is to ask to the query API to wait from indefinitely to a small amount of time. Indefinitely is generally used to must only be used in unit tests in order, because you want to have unit tests with all data set up for the test. So you wait for the indexing engine indefinitely. At query time, generally, the application does not really need to deal with eventually consistency, because if you have normalized everything, you don't really need to query in another one garden, in a different bounded context in order to understand what the shape of the data is. You have everything in your bounded context. I suppose that any one of you knows how the indexing engine works, but basically the issue is that documents arrives in the database, the indexing engine kicks in, analyze your index shape, and start indexing documents. And this process can take time depending on the number of indexes and the number of documents. And so it can happen that the query does not return all the data you request. It's just a matter of dealing with it from the application point of view. I try to compare that with the async API of the Win8, the Metro programming style, where everything that lasts more than 50 milliseconds must be async. If you are used to Windows Form development, try to think that everything will be async, and you have to just deal with it. Okay, maybe in the beginning it's hard because application.do events, it's much easier. And but if you start to live with the async fashion of everything, everything will be much easier in the end. So it's just a matter of from the application user experience point of view, understand that a query is not expected to return all the data you are expecting to have back. And I've never had any issue with the eventually consistency with the customers. Once we started to embrace CQRS and event sourcing and domain-driven design in general, we had no issues at all with eventually consistency. The normalizing stuff, it's the best way to go in order to. OK, we have just said this. And the last thing is that shard and replica, as we have told, is not it's from the setup point of view, it's really, really, really easy. You can set up a sharded document store in seconds, but think about it really carefully. because changing the shard strategy in production is really a complex thing. So, and it's a really long thing that may takes offline your servers for hours because you have to update a lot of stuff. So if you want to go with sharding, think about why you need to go with sharding and how to shard the data, because changing it afterwards, it's a complex stuff. Setting up replica, it's, on the other side, a master-slave replica is the easiest thing ever. A master-master replica compared to an active scenario with a relational DBMS is the easiest thing ever. But you have to deal with conflicts. And dealing with conflicts can range from an easy thing to a really hard thing. It basically depends on the shape of your data. If you go with CQRS and event sourcing is the way to go to deal with conflicts, because you don't have conflicts, basically. You have an insert-only scenario, so there is no way to update some other data. But if you don't have a fully event sourcing scenario, you have to deal with complex. And maybe it's not always easy to say this overrides that. You have to ask to the end user, do you want to merge? And the user, it's basically a matter of user experience you want to give to your end user. And so that's it. I finished. I hope I've not annoyed you too much. And if you have any question, I can try to answer them. Otherwise, yes, basically the question is if you have, if I understood correctly, if you have divided an aggregate into more documents, will you use indexes to rebuild the original document? We can do that. We can use indexes or much better transformers to recreate the original shape of the data. And if you have time in the next session, we'll see a sample of that. What we realized is that from the use case point of view, you don't really always need the original document. Think about a blog post that has, as Oren wants, that has thousands of comments. You don't really need all the comments every time. The first time you show the blog post, you need maybe the last 10 comments, and then you let the user page through the comments. If you have a single document, the only thing you can do is load everything and put into the user screen and maybe discard something after you have loaded it. You can use, otherwise you can merge things at query times, maybe using the pretty simple include features. That is basically saying, okay, include this documents within this query, so do a single round trip to the server and get back everything in one single query. This feature was originally thought to prevent the select n+1 issue with the relational databases when you for each on a property and you issue a new query for each. And this is the easiest way. If you want, otherwise, if you have a blog document with maybe the blog post and the abstract data, and you just want to show the abstract and the first top 10 comments, you can use a transformer. A transformer is basically something that runs within your query at the server side and can change the shape of the data before returning the data to the client. So you issue a query on blog posts, and what you get back is the abstract and a bunch of comments. Because in that specific scenario is what you need. And so you can separate stuff. And when you read that, you can have back the shape you really need.
It's not easy.
No, it's not easy.
And sometimes you have to change that, and sometimes you need the, one of the, of course, the normalization, right? But it's not always important.
No, it's not at all.
The aggregate could be spread to a lot of.
Yes, conceptually, one of the hardest things, from my point of view, with domain-driven design is exactly that, to understand the boundaries of bounded context. Because we tend to think we as a company, when arrive to a customer, tends to assign bounded context to departments or organizational units, saying that you are the accounting people, so you are a bounded context. If you speak about the concept of an address, it's your concept of address. And from the logistics point of view, there's a different address. You call it the same, but they are two completely different concepts. In reality, what happens is that while the application evolves, maybe these concepts are not so clear, and you tend to get back and change things while working, because each time you develop something, you understand better what's the business problem you are trying to solve is. I think that it's a problem with domain-driven design we have to live with. It is not a recipe to solve a problem, like saying it's not a formula that you can apply to a problem and say, okay, if you apply this formula, it just works. It's just a methodology you approach with the customer, and the best thing you can do is to try to make what from the domain-driven design point of view is called the ubiquitous language. That is the best way you have to understand how bounded contexts are divided. So you have to carefully listen to people that works daily in the company with the functional problems. And you have to really listen to the way they use their noun and verbs in order to understand what is a concept, like an aggregate root, what has a different meaning in different contexts, address in two completely different bounded contexts, and what is an event. Because in my point of view, it's really easy to solve the domain-driven design problem using event sourcing, because the events are the best way to connect different bounded contexts. Because once you have isolated context, it's really hard to, okay, let's say, because Eric Evans told me that they are totally isolated, they cannot speak to each other, but in the end, I can bring up the phone and call someone in another department. So they can speak. How they can speak, and events is the best way to make them connect.
So the same question actually regarding how to support the structure report. So of course, from the service-oriented design or architecture report, there's some way to keep the nice way or some simplified way. Actually, one of them which we are trying to research is service bus.
Okay, I'll ask you to postpone this question to the other session, because we are going to deal exactly with that problem. So maybe this session will answer to your question before, because the other demo is using N-Service Bus to move around events with the RavenDB and stuff like that. So
the knowledge topic is regarding sharding, right? Once you apply the sharding, it's not easy to change. We thought about apply the sharding from the beginning, but we did not do that because it's probably just the same. What do you think from the RavenDB viewpoint? What's the possible way to that make this type of change?
I do not really think that from the database point of view, the database engine point of view, there is an easier approach to sharding. Maybe there can be tools to reduce the pain that you have to face when you have to move data around shards. Because if you need to, let's imagine that you have orders, and in order items, they're products, and products are sharded. So you have the order item whose foreign key points to a product that is on a shard. So that conceptually foreign key, as in the identifier, the shard key. If you want to move products, if you want to change the shard strategy of products, the pain is that you have to update orders, and you have to update everything that has a relation with a product, because the normalized version doesn't work anymore if you updated the shard topology of products. The only way to do that is currently is a manual way. So you have to write code to do that. You have to move to move products in the new location, change the product identifiers, basically creating a new document with a pre-assigned key, and then you have to update all the orders. Maybe in the future there can be a tool to achieve that, saying, okay, that's the shard strategy, move this server to this. But
Sharding strategy by default says given this shard key, this is
exactly.
you can say
I'll tell you.
this shard key exists all that. That way you can move the data. What if the shard key move the data in that?
Okay, that's it.
So what can use some indirect reference used to build up the direct type instance.
But that you cannot leverage the power of blind queries. I understand what's the point. You say, I have my concept of key, and then you have a storage, let's say a dictionary, that translates my concept of key to the document key. But you have to issue at least 2 queries to get the original document referred by your key. And the problem is that if you are sharding data, you are sharding data for a specific reason that generally is availability and distribution. And then if you introduce that, let's call it a dictionary, an hash table, it means that you have a single point of failure where everything must pass to understand how to translate keys. This is basically the way Mongo works. Sharding in Mongo works using a shard server, and there's a single server that knows the topology of the shard. In case of RavenDB, is the client that knows the topology of the shard. That is much better because you do not have to replicate that server. Basically, each client knows where to find things. And on the other side, having a single server that knows how the shard is set up means that if that server fails, everything is failed. That's why, if I recall correctly, from the replica point of view, what happens is that the first time the client connects to the server, it downloads, let's call it, the replica topology and store it in the isolated storage. So if the master server fails while the client is shut down, when the client is bringed up by the first HTTP call, for example, it already has the replica topology, and it can connect to the slave server, for example. Moving this data on the client is the best solution. Maybe it's not the best solution from the maintenance point of view, because if you have a lot of clients around, for example, desktop applications, if you want to update that topology, you have to update all the clients. But I prefer to live with updating all the clients that with a failed system because of the shard server that is down. Okay, last question? No. Okay, last one. No, but I think that we'll end it offline.
It's a short question. I was wondering, did you find that document databases, the database gets more coupled with the
Yes.
originally created? Other applications you make use of?
I strongly think that the domain-driven design concept that says the database is mine, and if you want to touch my database, you have to come to me instead of touching the database, is the best thing a development team can embrace. And what it does mean is that integration at the database level is evil because it prevents you from changing. If you try to integrate application at the database level, it simply means that it's impossible to evolve because you do not know who is integrating with that database. And you are locked in that situation. I've seen relational, I suppose that everyone has seen relational database where there is, in the city column, there was a postal code because we do not have postal code in that shape 2 years ago. So if the date of the document is before 2010, then that column means that. That happens because people try to integrate at the database level. The database belongs to the application. Well, the database belongs to the bounded context. And in the end, we should be able to have different databases per bounded context, and maybe multiple databases per bounded context. Because as Oren said, RavenDB is an amazing piece of software, but it doesn't solve every single problem related to databases. So maybe in a bounded context where you need a lot of business intelligence, the best choice is to put also a relational database to replicate stuff to that relational database and put on top of that something like business objects or reporting services. And it's just the meaning of being able to separate stuff. That is with huge teams that are really attached to this, I would say, legacy thinking that the database is the Bible and there must be only one single database. The domain-driven design concept of separating stuff in bounded context and every single bounded context is isolated, it's the most complex thing to embrace. For the team, it's just a matter of mental switching, because then you start thinking, how can I connect things? How can keep things up to date? Events. And in the next session, we'll see how to. OK. Thank you very much.